Here's a solution to one of the homework problems where we're starting off with a function that describes acceleration, and then we have to work our way back up to position. So remember, acceleration is the derivative of velocity, and velocity is the derivative of position. And so the fundamental theorem of calculus is going to tell us that when we integrate the derivative of velocity from 0 to t, that will be the velocity at t minus the velocity at 0. The reason that's relevant is that the derivative of velocity, this value that we have here, is acceleration, and we're given that acceleration is a constant function, so it's just a number, the number 90. So this v of t minus v of 0 is going to be equal to the integral from 0 to t of just the constant 90. And so that'll be 90x evaluated from 0 to t. Which is 90t. Now that is the difference, v of t minus v of 0. Because v of 0 is given to be 0, then this term drops away. But it doesn't always drop away. It's just, we can cancel it out because v of 0 is 0. So the net result is we have that v of t is equal to 90t. So that's the velocity function that satisfies the requirements of the problem. Part A of this question, though, is asking us what is the position function, and we can play exactly the same game. So the position at t minus the position at 0 is what the fundamental theorem of calculus tells us is going to happen when we integrate the derivative of position. But the derivative of position is just velocity. So this is the integral from 0 to t of 90x dx, because the derivative of the of the position function is the velocity function. So if I do this antiderivative, this will be 45x squared evaluated from 0 to t, which is just 45t squared. Now again, that is 45t squared is the difference between s of t and s of 0. But again, we're also given that s of 0 is 0. So just like the other time, this can be ignored, not because it's not important in the fundamental theorem of calculus, but because it's given in the problem to be 0. So this will be our answer to part A. The position function, the position function s of t is just 45t squared. Notice that that's easy to check because we can compute the second derivative of that and find that it's the constant 90. We can also plug in 0 into that function and 0 into its derivative and see that all the conditions are met. The B part asks how far does a racer travel in 6 seconds? Well, s of 6 is the position of the of the racer at 6 seconds, and so we're just plugging that in to our position function. So whatever that is, measured in feet. The C part asks how long will it take the racer to travel 1/3 of a mile. So that's the same as it saying find t, so that s of t is equal to 1/3 of a mile. Now this is a little tricky because the units for s of t are feet, not miles. So we need to convert 1/3 of a mile to feet. A mile is 5,280 feet. And so 1/3 of a mile is 1/3 of 5,280, which is 1760, I believe, feet. So this is the question. Find t so that s of t is 1760. So in other words, we're just trying to solve the equation 45t squared is equal to 1760. Solving that for t. I'm not going to do that. There's not much point. The numbers should be randomized in different versions of this, but to solve that, we would just divide both sides by 45 and then take the square root of both sides. The d part is more direct. It's actually giving us a measurement of position in feet. So part D is just saying find t so that the position is 300 feet. So in other words, we want 45t squared to be equal to 300. And again, that's just solving the algebra equation. Divide both sides by 45 and take the square root of both sides. The E part has two parts to it, two steps to it, because they're giving us a specific speed that they're interested in. And so I would first find t so that the velocity is equal to 162. Don't forget that the velocity function is sitting right here. So this is a simple enough thing to solve. We're trying to set 90t equal to 162 and solving for t. That'll be 1 point something. The second step to this would be to plug that t. That tells us the moment in time where the velocity is 162 feet per second. The question is, we want to know how far the racers traveled at that time, and so I plug that value of t into my position function. So we find the time it takes to reach the speed 162 by solving this equation, 90t equal 162, and then we plug that value into s of t, which is the 45t squared formula. So we're going to use both formulas in that to get our answer for how far the racers traveled when it reaches that speed.